Today I'm going to be presenting 2020 AMC 8 problem number 22. When a positive integer n is fed into a machine, the output is a number calculated according to the rule shown below. If n is even, then do n divided by 2. If n is odd, then multiply n by 3 and add 1. For example, with the starting input of n is equal to 7, the machine will output 3 times 7 plus 1, which is 22. Then if the output is repeatedly inserted into the machine 5 more times, the final output is 26, as shown by this chain over here. When the same 6-step process is applied to a different starting value of n, the final output is 1. What is the sum of all such integers n? So for this problem, there's a few things to note. The starting and all values of n have to be positive integers, and that it's best to go backwards with this chain because otherwise we have to check all the possible starting values of n, which would be harder. So let's start. So the first number is 1 because that's the ending value. The next number has to be 2 because there's no such integer such that when you multiply by 3 and add 1, it gives you 1. But there is an integer when you divide by 2, it gives you 1, and that's 2. No such positive integer. Notice how 0 is an integer, but 3 times 0 plus 1 gives you 1. But it says when a positive integer n is fed into a machine. So then you have 2. You do the same thing again, and the only possible value is 4 because there's no such integer such that if you multiply by 3 and add 1, that gives you 2. But there is an integer that when you divide by 2, it gives you 2, which is 4. Now 4 has two different values, 1 and 8. Notice how 1 times 3 plus 1 is 4, and 8 divided by 2 is also 4. So 1 and 8 both fit the conditions of this machine. And now 1 is back at this start, so we know the only integer that 1 could go to is 2. 8 can go to only 16 because there's again no such integer such that if you multiply by 3 and add 1, it gives you 8. Same way, 2 has to go to 4, as in the beginning, but 16, it can be written as 5 times 3 plus 1 or 32 divided by 2, so both of these values work. So we go again, and this time, 4, as in the beginning, can be 1 and 8, because 1 times 3 plus 1 is 4, and 8 divided by 2 is also 4. But for 5, there's no such integer, again, that when you multiply by 3 and add 1, it gives you 5. But 10 divided by 2 is 5, so 10 is the value. In 32, there's no such integer that if you multiply by 3 and add 1, it gives you 32. But there is an integer such that when you divide by 2, it gives you 32, which is 64. So now 6 steps have been completed, as shown by these arrows. If you use any of these paths and count till the ending number 1, 8, 10, or 64, 6 steps will have been completed. Here's 1 arrow, 2 arrows. Let's say we go this path or something. 3 arrows, 4 arrows, 5 arrows, and 6 arrows. If you go the other path, 6 arrows will have been completed. If you go to the left side, same thing, 6 arrows will have been completed. And 6 arrows means 6 steps have been completed. So we have to find the sum of all such integers n. These are the all integers n that if you do this process, it gives you 1. So now we find the sum of them. 1 plus 8 plus 10 plus 64 is 83, which is option E.